Afternoon. Welcome to hardening AWS environments and automating incident response for AWS compromises with Andrew Krug and Alex McCormack. Before we begin, just a few brief notes. Please stop at the business hall located at Bayside AB. The Black Hat Arsenal is on the Palm Foyer on level 3, and the Arsenal reception is at 5 p.m. today. If you haven't picked up any merchandise or any books, today is the last chance you have. If you want to stop at the Black Hat store, please do so today. And you can visit the Kali Linux workshop, the Kali Linux lab in Mandalay Bay A. Well, that's everything I've got. Thank you for putting your phone in vibrate. And without anything else, please give a warm welcome to Alex and Andrew. Thank you.
Good afternoon. Welcome to our talk. My name is Alex McCormack, and this is Andrew Krug. Andrew and I met about 2 years ago, and we started working for the same company building security things. And we started moving these security things into AWS. And it became quickly apparent that AWS really strives to facilitate orchestration and instrumentation in many of the AWS ecosystem. So we started to have these long conversations about how this programmatic access could be used to help augment all aspects of the incident response workflow. And thus, this talk was born. This talk is going to cover how to use these services and these APIs provided by AWS to better handle an incident. Best practices advise following predefined practice procedures when dealing with a security incident. And we'll look into the common incident response methodology and show where augmentations can be made to address the use of AWS. We'll discuss how to use AWS to pipeline and automate the tedious tasks associated with digital forensics, and how to leverage storage and compute capabilities to process this data. Along the way, we'll be looking at tips to harden AWS environments and to make it more difficult for attackers to reach their objective. This is a lot to talk about. We're going to be introducing 4 tools that we built to demonstrate incident response capabilities within AWS. And we'll be surveying many of the mechanisms AWS and other third parties have made available. Unfortunately, we only have a short amount of time to cover these areas, so be sure to download the slides, download the white paper, and follow the links to find additional resources to find out more. As we discuss strengthening the security posture and increasing capabilities for an incident response procedure, we should keep in mind the risks we are trying to minimize. Over the past few years, we have seen periodic reports pop up on Hacker News of developers accidentally publishing their AWS access keys, heading to bed, and waking up to skyrocketing bills and emails from AWS support. In fact, in December of 2014, the Register reported a developer named Andrew Hoffman lost $2,300 in an AWS access key compromise. And as recently as last year, a Quora user reported losing $50,000 in an AWS compromise. And while these stories are sensational, I have yet to see a case where AWS didn't work with the victim and forgive the cost. But why is this happening? What are these keys, and how are attackers getting a hold of them? So AWS keys are provided by AWS so that developers can programmatically interact with the AWS SDK. A key is tied to an IAM user, and that user has policies dictating what the user can and cannot do. But as we saw with the last slide, the developer setting up the policies may fail to make them restrictive enough to prevent abuse should the key be leaked. And the keys can be leaked. Oftentimes, it's a simple mistake where a configuration file is accidentally published to GitHub or Bitbucket and is now available for the world to see. But even if developers are careful enough not to publish their keys, they may store them on an EC2 instance to run jobs. Suppose, for instance, a developer created an EC2 instance with a small web server that accepts an image, resizes that image, and then stores the new image in an S3 bucket. The code needs to write to an S3 bucket, and the developer may have stored an access key on the EC2 instance in order for the code to use. But now imagine that image processing was susceptible to the image tragic class of vulnerabilities we saw identified earlier this year. An attacker could gain access to the instance and discover the key. The attacker could then use that key to spin up lots of other instances and mine cryptocurrencies. But mining cryptocurrencies is not the attack of a sophisticated attacker. Cryptocurrency attacks are noisy, and it's just a criminal trying to make a quick buck. More worrisome is what can happen if an attacker obtains high-level credentials and then stays quiet. What could a quiet, patient, sophisticated attacker do with that level of access? Sophisticated attackers may be interested in using compromised credentials to further their own access into an organization. A recent blog post by Daniel Grzelak discussed some possible things an attacker could do after obtaining IAM credentials. For instance, you could find direct connect access points and possibly tunnel through an organization's VPN back into their home network. You could list their users and support tickets to get a better understanding of which users you should target for further analysis. Daniel also has a blog post detailing a sneaky attack that would give users a backup access keys to every IAM user in an organization. But imagine what an attacker could do if an organization uses even more of the ever-growing list of services provided by AWS. What can an attacker do if they had full control of the Route 53 DNS service? What kind of data can an attacker get by snapshotting live instances of storage volumes and examining those instances on their own instances? It's with these scenarios in mind that we'll attempt to increase our security posture and increase the efficacy of our incident response procedures.
So we're all likely familiar with major phases of incident response. In case you're not an incident responder and you need a little refresher, here they are on the screen. They boil down to preparation, detection and analysis, containment, eradication, and recovery and post-incident activity. We'd really like to help you with the last two phases of that, containment, eradication, and recovery and post-incident activity. But if you perform these steps today, you know that they're a little bit more wibbly-wobbly, and they feed back into each other to help you have better security posture over time. And continuous improvement is a really great segue into defining what DevSecOps is. First, where there was dev and ops, next there was a fusion of the two, sort of a movement of making developers sysadmin-y. But now we actually have DevSecOps, which you might define as the coming together of security operations and development, which gives rise to the possibility of automated incident handling or machines performing IR on machines. So to put our tools that we're going to release in the talk in context, we'll show you some of the facilities that already exist in AWS to fill these gaps. So when you're doing IR in AWS, there's a few things that can be really challenging. One of the first that I identified in my research is that AWS is global, meaning that it's very easy for you to have a server presence in Ireland or Singapore, but that can make it equally difficult to locate an instance that's compromised inside of that global cloud. Managing and auditing developer credentials can be very challenging, and due to the depth of configuration in those environments, it can be difficult to spot configs that are less than ideal. AWS has lots of built-in utilities that we can leverage to make it more difficult for attackers to gain access, and we can use that to increase visibility of what's going on in the AWS environment. We'll look at those services now to see how they help.
The first thing we're going to look at is CloudWatch. CloudWatch is a monitoring service you can use to monitor metrics of AWS resources or even custom metrics from your own applications. Alarms can be placed on these metrics so that if the metric is exceeded, an action is taken, such as sending a notification or even terminating a resource. One of the most common alarms is one which watches the estimated charges of your entire AWS account. Other EC2 alarms can be created for metrics like CPU utilization, network in and network out, and then there's also metrics for services like EBS, S3, SNS, and logs. Additionally, CloudTrail is an AWS service that records data about AWS API calls. The API calls may come from the AWS Management Console, the CLI, or the SDK. For each call made, the record will contain the time of the call, identity of the user making the call, source IP address, the request parameters, and the response parameters. The forensic value of these logs cannot be understated. In the event of an IAM compromise, CloudTrail could be the only thing indicating what actions an attacker took. You can even use CloudWatch to monitor the number of incoming events coming into a CloudTrail. This is especially useful in environments where maybe there aren't that many API events normally, and so by seeing lots of activity in a small amount of time, you know something suspicious may be happening. Finally, just to reiterate, if you get one thing out of this talk, you should turn on CloudTrail.
Now we get into some of the fun stuff. Amazon has a really great framework for bootstrapping orchestration, allowing you to run commands. Sometimes in the interface, it's referred to as EC2 command. Sometimes it's referred to as simple server management. It works for Windows and Linux, and it uses an IAM role to do that. There's been a lot of talks this week about IAM roles and how they work in AWS, so I'll just sum it up as an IAM role is a delegation of privilege, allowing a workstation to perform some action in the AWS account. They can be good and bad. We all know that they're bad if an engineer makes those roles too privileged, allowing an attacker to escalate inside your environment. And you may be asking yourself why you would even want a facility to run orchestration-based commands in your environment with things out there like Ansible, Puppet, and Chef. This is just one more thing. I find this to be a really useful environment default because it gives you an out-of-band management method for taking back control of an instance should an attacker happen to lock you out. So let's imagine that you had an instance that's popped and an attacker revoked all the SSH keys on that system, but you'd really like access because you'd like to acquire live memory from the system and do post-analysis and figure out what the attack vector was. If the SSM agent is installed, you can simply go into the SSM dashboard and you can select Run a Command and then target the attacked instance, input the command to echo out another SSH public key, run that, and you've effectively taken back control of that compromised instance. And that's notable that that's an agent-based process where there's a client that sits out there on your, all of your boxes in your environment, and it periodically pulls the API. So it's not unflappable in that an attacker could just elect to shut down that agent, but this is one way that we can use to sort of take back control. There's a great presentation that I have to mention from last year's Amazon reInvent of an engineer also using code deploy packages to perform sideloads in a similar manner to gain control of a compromised instance after all of the accounts access was revoked. Now, personally, when I first started using AWS, I didn't really understand IAM roles, and I didn't have a firm understanding of what its purpose was at all. I found them to be very confusing and buried too far in the dashboard for me to use on my own, so I made mistakes. And as a result of those mistakes, I did things like generate IAM accounts and bury credentials within AMIs, which we all can agree today is pretty poor practice. So if there's a couple pieces of advice, that's to use least privileged roles, play with the roles, and audit their usage with CloudTrail. IAM roles work by attaching to an instance at runtime. It's very important to point out that if you launch an instance with no role or instance profile attached, you can never attach a role to it. So in my opinion, it's actually better to have a generic role that has a no IAM privilege than to not have the ability to modify that privilege later. So once that role is attached at boot time, the instance does what's called assume role, which is a special power the instance has to get credentials from the security token service. And those credentials are automatically refreshed before they next expire. So these are the bullet points from that last slide. Instance profiles can't be detached once they're attached, and instance profiles can't be added to a running instance. Moving on, we have to talk about AWS Config, which is a relatively new service where we really see some potential for automation in environments with regard to security. AWS Config is a trigger-based reality that will compare your environment against a set of rules and can take an action if they don't match the desired baseline. It's important to distinguish, though, that the term config here is a little oversubscribed in Amazon Web Services. It's both descriptive of understanding config changes and also enforcing compliance rules via the config rule engine. So you have one service that performs two very different functions, both assisting you in security, but in a couple different ways. Config keeps a timeline of what's changed, and config rules run periodically and determine whether your defined baseline matches the live environment. Config rules have a really nice interface to set up on initialization in your account, and config asks you three basic things. What resources should I be watching? Where should I store the data about watching them? And these little chunks of data that it stores are called configuration item states. And what other things in AWS are going to receive events if notified? Now, those little chunks of data that are the configuration item states are what makes config really powerful and able to do things like produce that timeline of all the changes to an instance. So here's a quick example of a timeline on screen. The instance I used to generate this particular timeline wasn't very old, so there's not a lot of data in it. But it does capture a lot of really great data that gets tracked via the config service. And it's really notable because all of this configuration item state data lives in an S3 bucket. This data persists even after that instance is terminated. So there's a lot of advantage to having config just watch over your environment. Config also gives you the ability to set up those rules I talked about that report on non-compliant resources, where you define what your idea of compliant is. In my example here, I use one of the pre-baked recipes for reporting on instances that have security groups open to the world. And you can set these rules to run at a periodic interval or at any time certain changes are made to your account resources, like provisioning an instance. Here's the output of config evaluating my account with resources for open access. And you can see now I have quite a few resources that I can identify that are non-compliant, and I could go fix those things or remediate them in any way that I choose. The real power, though, in these facilities comes from being able to use AWS Lambda to automatically resolve non-compliance through actions. For example, I could create a Lambda that would immediately remove an open access security group if it violated this compliance rule. So all the features are really here to build some nice automatic pipelines and remediation ability. So I actually have a demo here of using CloudWatch events, which works in a very similar way to AWS config to automatically turn CloudTrail back on if it's disabled by an attacker. So this is the rule that I've created in CloudWatch events. All it does is it looks at API calls and sees if something calls stop trail. Then I'm going to run a little script here that plays the attacker. It's going to disable CloudTrail, and then it's going to go into a loop seeing if CloudTrail has been reactivated. So you can see CloudTrail stopped.
There's the true.
And there it is automatically turned back on with a Lambda.
You got it.
I lost the presenter display here. Just bear with me for 1 second.
We're so close.
Yeah, so close. Presentation hard. All right, so I would be also remiss to mention that there was a great talk also at AWS reInvent last year called Wrangling Security Events in the Cloud that takes a little bit deeper dive into using these Lambdas. We don't have time to go through many of them today, but you can see how powerful they could be. So when we first started building this talk back in May, we thought it would be really cool if you could take an IAM policy, generate some denials, and then turn that into a whitelist. Well, that turned out to almost already exist inside the AWS tool space, so we decided to just take a look at that. That tool in Identity Access Console that exists for you to use is called Access Advisor. And it allows you to start off by casting a broad net when you create a custom IAM policy, and then looking to see when those IAM permissions are used so that you can revoke them later. Let's blow up that small graphic for a bit. And here in the little red circle, you can see a permission and that permission was never used. So I know that I can go ahead and peel that off the IAM policy. So some advice to take away from that: use those custom policies, audit them using the Access Advisor, and then revoke the permissions you don't need. Now this brings us to our tool releases, which is sort of the main focus of the presentation today. When we surveyed the security toolscape for open automation tools around incident response, we discovered a few things. The first of which was that there just weren't that many tools out there in the space, and we absolutely wanted to make one, and we wanted to release it sometime this year. Second was that the tools that did exist assumed a lot about the person using them and about the AWS account setup. We wanted to add a tool to this ecosystem that was simple, easy to use, proof of concept for driving the AWS API that assumed nothing as well about the security posture of that account. So our goal was simple. We wanted to be a free, open incident response toolkit tailored for Amazon Web Services. We wanted to primarily help first responders by automating workflows using Amazon's Boto 3 pip module. And so that brings us to our first tool that we're going to release. It's simply called AWS IR. And at this point, it's what I would call a strong alpha for demonstrating what's really possible using the Amazon API and mitigating a compromise and preserving all of the forensic data available. Let's take a look at how it works. At the beginning of the presentation, Alex talked about two types of compromises, key-based compromises and host-based compromises. Our tool handles both of those. That means that the key compromise is really two phases. One, locate the compromise access key, and two, simply disable it and then audit to see if that key is used. But really, it looks a little bit more like this. A key-based compromise needs to feed back into a host-based procedure. When keys are used to gain persistence in other instances, those need to be processed as part of the same incident or case. So this is a little demo of our key compromise in action. That's the help dialog for the tool, and you can see we're just running AWS IR, feeding it key compromise, giving it an access key ID. It disables the key, and then it writes out a complete log for that to an S3 bucket for the case to get you kicked off. And then I'm going to keep that last little part that printed out at the bottom a secret for just a few more minutes as to what that is. Now on to the host-based compromise. AWS IR works almost the same way for a host-based compromise, but it takes an IP address, an SSH key, and a user that you'd like to use to try and gain access to that instance. So in this demo, I'm just going to feed the AWS IR utility that IP address, username, and SSH key. It's going to perform an inventory of all AWS regions and availability zones, quickly locate that instance, do a few more things to it, acquire memory to an S3 bucket, and log all those actions. And so you can see here on screen a quick S3 LS of all the things that we write out. And I'm going to talk a little bit more in detail about what those are and why all those actions are important in the IR process next. AWS IR begins by pulling down all of the AWS region inventory data globally, dumps that instance data, and flattens it all into a very simple dictionary for quick search. If you've ever tried to hunt a single instance in the AWS console, you know it can be a bit of a chore. You have to go to every region and put in the IP address, so it can become the proverbial needle in a haystack. So this effectively takes that out of the equation. It lets you find that instance very, very rapidly. Next, we felt like it was very important to quarantine the instance. So the first thing that we do is create a deny egress security group and only allow the workstation access to wherever you're running AWS IR from. The next step is that AWS IR generates a case number and creates an S3 bucket to store all of your forensic data that you're collecting from that instance. Next, we use the API to take a snapshot of any volumes attached to that instance, applying a case number and incident tag as metadata to those for reference later. Before shutting down that instance, we want to grab any volatile data. So we built a custom engine that we'll talk about in just a bit to grab that memory, but we also grab memory and put it in the S3 bucket. And finally, we grab any pertinent instance data, and that means AWS-specific metadata, console logs, and even a screenshot of what was on the system's regular console at the time. And then we power down that box. To recap, that's 7 steps, 1 command line, all the evidence, all over AWS globally. Fair warning, though, if your servers aren't in autoscale groups, we will just power them off. If they are in an autoscale group, we can power them on. Your autoscale group will do its job. It'll provision another instance, and your app will stay up. But if you run this, rest assured, the instance will be stopped. So about that memory engine. The memory engine was the very first thing that we built for this project, and we hope that you'll find it really useful. We worked really hard to make this memory engine relevant for on-prem data centers as well as AWS. So everything that I'm going to show you now applies to your on-prem environment the same as it applies to the cloud. We really love the work the Lime team did on remote memory acquisition, but we really didn't like that we had to build custom kernel modules to make the process really reliable. To add to that, all the data between the acquiring workstation and the system that you were acquiring goes over the network in the clear, and we all know that's bad too. We had a member on our team who couldn't be with us today who really took this challenge and ran with it. And that person's name is Joel Ferrier. If you want to get in touch with him to ask memory acquisition questions, he's in the third from the last slide. But he poured a ton of time into making this memory acquisition really solid. The memory acquisition's name is Margarita Shotgun because it's a Lime parallelizer. It firstly uses Python Paramiko, which is an awesome feature-complete implementation of SSH. It SSHs into the compromised system. From there, it determines the running kernel, checks to see if a kernel's been pre-built in our kernel module warehouse. We have most kernels pre-compiled for Amazon-certified AMIs for you, so you don't have to figure out all the kernels that exist in your environment. You just have to fire this tool against it. If it's a certified AMI, it will work. Once a kernel module is identified, it SCPs over the kernel module, spins up an SSH tunnel, and then begins streaming the memory to the system that you're acquiring. During that streaming process, Margarita Shotgun starts a multi-part upload to an S3 bucket, which effectively makes this memory acquisition process storageless. And that means that it scales very, very well. If you need to acquire one instance or 1,000 instances, the disk requirement is the same because the memory is streaming directly from those instances right into an S3 bucket. I should note that the memory acquisition engine also can be fed a YAML file of systems if you need to acquire them en masse, or you can provide them on standard in. I'll show you a quick demo of Margarita Shotgun acquiring 4 instances at once. This is that YAML file. That's the help dialog. Has a lot of other features that we don't have time to cover. But you just feed it that YAML file, and then there it goes. It's off acquiring 4 instances all at once, streaming that memory live to an S3 bucket. So you could run this in a Docker container. You could run it on a regular workstation, pretty much anywhere that you can pip stuff. Someday we might even consider running it in a Lambda if the time constraint works out. So now, about that kernel module warehouse. I mentioned earlier that we were searching that. This is our own addition to the Lime space. It's a Ruby gem that drives Docker to compile all the modules for all these different environments. And if you run it on Amazon Linux, it'll compile for AWS Linux as well. The output of that tool is just an S3 bucket full of all the potential Lime modules. We have a default bucket in the code base, and thanks to some support from Amazon, we're going to host that more or less indefinitely for the project. But if you're a little bit paranoid, like some people are, you can host your own version of this repository. There's a trust no one configuration where you can override the URL of that module warehouse with an environment variable or a config hash item.
So back into the dealing with an incident scope. If you remember back when we were talking about AWS IR, that module automatically collected evidence and put it in an S3 bucket, or it created snapshots of the attached volumes of a compromised disk. In almost every case, simply collecting the evidence and terminating the instance is not enough. You'll need to review the evidence to determine what was taken or how the attacker got in, to determine how to resolve this incident. To help in this area, we created a workstation to demonstrate how to glue together multiple open source forensic tools. The workstation is an AMI being released today that anyone can use in their own AWS environment. It features a friendly web interface that glues together the workflows of several open source tools. There are several ways to start the threat response workstation AMI. You could start it from within the AWS console, but it requires some setup. So to make it easier, we added a command to the AWS IR tool called create workstation. And after running either the host compromise or key compromise command, AWS IR will provide you with the command to launch the workstation. Additionally, you can also just add the -c flag when running either the host compromise or key compromise command, and it'll spin it up for you once it's done collecting the evidence. After the workstation is finished launching, the user will be given an SSH command so they can route all their traffic through their browser, through the SSH tunnel, and into the threat response workstation. So the first thing the user is going to see when they connect to the web app is the dashboard. The dashboard contains a few widgets to help the user understand their current AWS environment. The first widget displays how many instances are running on each AWS region. The next widget displays how many instances were launched within the last 24 hours. Finally, a widget displays the different types of AMIs and how many are running across your entire AWS infrastructure. With these widgets, a user can better orient themselves to determine if something looks out of place. From the dashboard, the user can then choose the Acquire, Analysis, or Advice tab. Let's take a look at the Acquire tab. So the Acquire tab demonstrates several possible features of an IR workstation. The first feature is a full text search across all of your AWS regions. Just as AWS IR collected an entire inventory globally of all your regions, the workstation will do the same. This Redis-backed search is very fast and facilitates search based on AMI ID, IP address, or availability zone. Now, the search provided in the AWS console is much more feature-rich, allowing searches across things like tags or SSH keys, but the AWS console does limit your searches to a particular region. Next, Acquire does what its name suggests. After you locate another instance to investigate, you can acquire more evidence on additional hosts. It leverages AWS IR to facilitate the collection of disk, memory, and everything else AWS IR can collect. After you've acquired enough evidence, it's time to start your analysis. So let's take a look at that tab. The Analyze tab shows how we can use all of the facilities within AWS IR and with several open source tools to facilitate compute and storage resources. The two main analysis mechanisms we demonstrate are for memory and disk. Memory can be investigated at the push of a button. By pushing the Analyze button for a selected memory dump, the workstation will download the LIME file right from the S3 bucket and into the workstation. A Docker instance is then run with volatility, and a JavaScript-based terminal shell will appear right inside the browser. This saves the user from having to download what could be a possibly large LIME file from their cloud all the way to their local machine. The Analyze tab also facilitates the processing of disk information. When a user views the disk portion, the UI will show all the disks associated with this case. When a user clicks the Add button, the disk will be processed, a Plasso file generated, and that Plasso file can be viewed with TimeSketch. For those of you who don't know, TimeSketch is a case management tool that makes it easy for multiple analysts to analyze timeline files and to note significant findings that they have found. TimeSketch is still experimental. It's a proof of concept tool, but we think it's pretty cool, even though Google describes it as, and I'm quoting, not an official Google product, just code that happens to be owned by Google, which I think is, I'm really glad GitHub repos don't have feelings, because that's just sad. Now, anyone who's ever tried to set up log to timeline will know that it can be a painful process. So we've automated the entire ingestion and delivery to make processing a disk as simple as clicking a button. Actually, it's clicking a button twice, but we'll explain that. So when the user clicks the pink Add button in the dashboard, Threat Response starts processing the instance within EC2. The way it does that is it starts a processing instance within EC2, and then it'll clone the S3 bucket. It'll clone the volume that was already snapshotted when the instance was identified as compromised. That clone is then attached to the processing instance and is processed. That processing then creates a Plasso file. Plasso file is stored in the case S3 bucket. And at this point, the blue-gray timeline button will turn blue, indicating the file is in the S3 bucket. So once the file is in the S3 bucket, it's ready to be imported into TimeSketch. TimeSketch also runs inside a Docker container inside the workstation. And just by clicking the green button, the Plaza file will be imported into TimeSketch. The entire process is completely scalable. If an incident requires processing of 100 disks, it's going to take the same amount of time as processing one disk. It all depends just on the size of those disks. Anybody who's ever used log2timeline also knows that processing disks does take some time. You can spin up as many images as you want, but you still have to read gigabytes and gigabytes of data. So you're going to have to wait for it. So to help, we want to show you how this works, but we're going to skip processing because no one wants to just watch a progress bar go across the screen. So instead, what we're going to do is we're going to show three snapshots, one that's already been processed, one that has been processed, and one that's already imported. But just by clicking that button, we're already in TimeSketch. And TimeSketch has this really cool feature it's this really cool concept called sketches, where you import these timelines into these sketches. So now that we're in a sketch, we're just going to show that we actually really did import this file by doing a couple searches. I wish we had more time. We could look at all the other cool features that TimeSketch has available, things like custom views or filters or even graphing. The last part of threat response that we're going to talk about is the Advice tab. The Advice tab shows a web UI for the final project we're going to be releasing today, a tool called Threat Prep. Threat Prep is a tool for checking configuration settings for areas where changes could be made to either make attacks more difficult or to increase the forensics evidence being generated during an attack. Threat Prep can be used from a command line, or as in the case of the workstation, used in another Python project. Let's take a look at the checks Threat Prep performs. By default, Threat Prep will check each S3 bucket to ensure versioning is enabled. It'll check to see logging is enabled, and then that read and write permissions aren't open to the world. This is important because versioning will tell you what changed, logging will tell you who and when something changed, and the permission check ensures sensitive resources aren't accidentally exposed. Threat Prep will also check each IAM user to ensure multi-factor authentication is enabled. It will check if passwords or access keys have recently been rotated, and it will check to see if any user has the administrator access policy. If a user does have the administrator access policy, you should audit their usage in the IAM Access Advisor that we showed earlier. Threat Prep will check each VPC to ensure flow logging is enabled. Flow logging is a great source of forensic evidence that is often overlooked. Threat Prep will check each CloudTrail to ensure that log file validation is enabled, which can indicate if a CloudTrail has been tampered with. There's also a separate check just to ensure you have at least one multi-regional CloudTrail enabled. Finally, Threat Prep looks for simple best practices, such as ensuring that access keys are disabled on the root account, ensuring at least one IAM role exists, and that CloudWatch alarms are set for the estimated cost metric. So how does Threat Prep compare with Trusted Advisor? For those who don't know, AWS already has a service called Trusted Advisor that is included with most support plans. But those support plans are going to start at around $100 a month and increase depending on your AWS usage. The second problem with Trusted Advisor is that the checks are statically defined. You can't write policies that apply only to a group of resources, but because Threat Prep is a Python module, you can interface it with exactly the needs that your organization uses. There's also many shared features between Threat Prep and AWS Config. For larger organizations, configuration auditing should be done with Config. It is extensible enough that policies can be written for the unique aspects of an organization, and tying into Lambda can lead to automatic remediation. And without the rules engine, the cost of config is very affordable. However, for small organizations, rules cost $2 per month per rule, and that might be a little too high if the organization is particularly price sensitive. So we just introduced you to the 4 tools that we are releasing today. That's AWS IR for automated incident handling, Margarita Shotgun to facilitate memory captures, the Threat Response Workstation to pipeline analysis tools, and Threat Prep to audit your AWS environment. We want to emphasize that these tools are first release beta tools. In developing them, we made some implicit design decisions about the incident response process. But your incident response process is likely to be different than the workflows we automate. To make the tools work in most environments, we have to assume things like CloudTrail or config haven't been enabled yet. So while we hope these tools will be useful to you, at the very least, we encourage you to take a look at the code and borrow whatever you need to help automate your own incident response procedures. But we're not the only ones looking into this space. Let's take a look at some of the other projects that can help automate incident response within AWS.
Yeah, so we would, this wouldn't be a very good security talk if we didn't mention at least a couple other companies that are doing a really great job contributing open source projects to this space. One of the best things that you can do to learn to be better at security in AWS is to just experiment with it. And kicking the tires on some of these other open projects is a great way to do that. So don't wait to try out some of these things. If you think that the tools that we built are terrible, we want to hear from you. If you think the tools that we built are great, we want to hear from you. Either way, we'd love to hear from you. But do set these up in a test environment, and I'll talk about what that means in a second. Do start a security simulation program, and do things like have IR game days. So I have to mention what my idea of a test environment is, because this is something that I don't see done very well when I go out on consulting engagements. A lot of people intermix their development and test systems inside of the same cloud. And that looks like this. And they think they're doing a great job just because they have test systems, when it should really look like this. Separate AWS clouds, VPCs, and subnets for each instance of whatever widget you're building. That makes it, one, easy to identify what logs and other things are in which cloud, but also make it easier on your staff, since you can control who can do things like terminate instances in production. All the engineers in the second graphic have one thing in common. They've separated dev, test, and production to different AWS accounts, and because clouds are effectively free, it makes them more empowered. So in this case, security actually makes it easier for your staff to do their jobs. Security simulations are really great to have in part of your program, and we're running short on time, so I'm not going to deep dive into what security simulations are. But the bullet point about security simulation is that if you decide to do these, Amazon would love to support you in doing them, and all you have to do is let them know that you're going to do a security simulation. So please do that. So there are a couple of other projects in the space that I have to mention. In the keynote yesterday, we heard Dan Kaminsky retelling a story about being in a room with a bunch of bank executives sharing their security secrets. He recounted how mind-blowing it was to hear the executives say, "We share these secrets because we don't compete on security." And that was something that really resonated with me as someone who built open source software. We don't compete on security. So we want to be sure to point out a couple other important projects that exist in this open space where giant companies are putting out their secret sauce to help everyone here be better defenders. And let's be honest, defense is not exciting, but it is really important. We can't have great, flashy attack talks without an answer to them. So Netflix started open sourcing its projects very early in the game. The Simian Army has been around for a long time, and Netflix has been evolving it pretty much constantly. It has some compliance and security feature overlap with AWS, but no forensic capabilities. Plus, the quick start guide I found to be quite long. It's Java. My guess is it would take a while for any of you to get this going in a test environment, but you'd learn a ton. We really also have to mention Capital One Cloud Custodian because it's released earlier in the year. Truth be told, it was a little bit difficult for me to get going as well. This project needs a user base more than anything. It has so much potential, but it's brand new, and it really needs you as a community to get behind it and do things like file bug reports and write documentation. The reality is, though, easy or difficult, these projects all fill a need that exists. So you might prefer to look at it like this. Those four categories, if you can't see them all the way in the back, are incident handling, forensics, compliance, and continuous monitoring. The green squares mean that project has coverage in that space, and the red squares mean it doesn't. So no one of these open initiatives really cover all four of these areas. So we have a few features on the docket to add to our forensic tools over the next little while, but we have nothing really planned, because a lot of it is going to be based on your feedback from testing. These are some ideas, though, we had from talking with some of you over the course of this week. Features like isolating your IR incident data inside of a specific geographic region of AWS to deal with border crossing issues, or things as fun as carving memory automatically with AWS Lambda and then correlating that with threat intelligence. But I want to emphasize, none of this happens with all of you, without all of you. We want to change the conversation on open incident response software. So I want to challenge you, if you have ideas or even better source code that you're hiding in the basement of some company, to get that out the door and onto GitHub and in front of the community in a legal way. Like, don't just put it out on GitHub, of course. But we need your help to build these tools, because it's a lot easier to say, I'm not going to put something out, than I'm going to put something out that doesn't work as well as I think it should. All of you can contribute and learn from each other. So with that, I'd like to wrap it up real quick, but first I have to thank the two other members on our team who couldn't be here, Joel Ferrier and Jeff Parr. They're on our website, threatresponse.cloud. Give a quick tip of the hat to Amazon Web Services guys who were super supportive of this project. And this is where you can go to get the software. So if you really thought that this was a cool thing and you want to go play with it, we're going to release it later this week, depending on internet connectivity. I've got to turn those repos over, so go to our website, sign up for our mailing list, and you'll get an email. It'll be the only email you get. We love your feedback. And before we wrap it up, we'd like to just thank you for being here today. You've been a great audience.